Hello learners. Today in the series of applied chemistry, the topic is lubricants. Lubricants form an important part of chemistry in daily life. In today's lecture, we will be discussing lubricants, their types and their properties. A substance which can reduce friction between two surfaces which are sliding over each other is called lubricant. Lubricant reduces the coefficient of friction between two rubbing surfaces of the machinery. The loss of energy due to friction is considerably reduced in this manner. Thus, lubricant acts in several manners. For example, it acts as a coolant or heat transfer medium by removing the heat of friction generated as a result of rubbing of surfaces. Lubrication does not allow a direct contact between the rubbing surfaces. A thin film of lubricant lies between these rubbing surfaces under proper conditions of lubrication. In internal combustion engines, it acts as a seal by sealing the piston and cylinder wall at the compression rings. Hence, there is no leakage of gases at high pressure in the combustion chamber. Lubrication also avoids power loss in the internal combustion engines. Now, let us talk about the functions of a lubricant. It reduces wear and tear and surface deformation by avoiding direct contact between the rubbing surfaces. It reduces loss of energy in the form of heat by acting as a coolant. It increases the efficiency of the machine by reducing the waste of energy. It reduces expansion of metal by local frictional heat. It minimizes the liberation of frictional heat and hence avoids seizure of moving surfaces. It prevents or minimizes unsmooth relative motion of the moving or sliding parts. It also reduces the maintenance as well as the running cost of the machine to a large extent. And as discussed before, it also acts as a seal in internal combustion engines. On the basis of physical state, lubricants can be classified into the following types: liquid lubricants, semi-solid lubricants and solid lubricants. Lubricating oils come under the category of liquid lubricants. Sometimes they are simply called as lubricant or lube. It is a class of oils used to reduce the friction, heat and wear between the mechanical components that are in contact with each other. Lubricating oil is used in motorized vehicles where it is known specifically as motor oil and transmission fluids. It acts as a cooling medium, a sealing agent and a corrosion preventer. A good lubricating oil must have low vapor pressure, that is high boiling point, high heat stability, high oxidation resistance, non-corrosive property and adequate viscosity. There are two types of lubricating oils. The conducting lubricating oil means which can conduct electricity, and non-conducting lubricating oil means which do not conduct the electricity through them. Now the lubricating oils can be of four types: vegetable oil, animal oil, petroleum oil and blended oil. Talking of vegetable oils, they are commonly used as liquid lubricants. For example, castor oil, coconut oil, etc. They are also classified as drying and semi-drying oils. They are easily oxidized by atmosphere. Animal oils are the oils of animal origin. They are mainly animal fats. For example, tallow oil, whale oil, lard oil, etc. They are very costly, hence they find little use as lubricants. They are also easily oxidized by atmosphere. Hydrocarbons with higher molecular mass obtained by the fractional distillation of petroleum come under the category of petroleum oils and are used as lubricants. They are obtained from the paraffin residue, for example, paraffin oil, lubricating oil, etc. Then come blended oils. They are the mixture of vegetable oils and petroleum products. They show improved properties. Different oils are suitably mixed depending on the requirement. They are synthetic lubricants, about which also we'll discuss in detail later. Talking of formulation, typically lubricants contain 90% base oil and less than 10% are additives. Base is most often mineral oils, vegetable oils, or synthetic liquids such as hydrogenated polyolefins, esters, silicones, etc. The primary function of the base fluid is to lubricate and act as a carrier for additives. The function of additives is to enhance an already existing property of the base oil like viscosity, viscosity index, pour point, oxidation resistance, or to add a new property like anti-wear performance, corrosion control, etc. Now moving on to semi-solid lubricants. When liquid lubricants are applied to metal surfaces, the bearings or other parts are to be sealed to avoid the loss of lubricant due to deforming effect of gravity. But this sealing can be avoided by using lubricants which are capable of resisting deforming effect of gravity. This type of lubricants are used generally in the semi-solid form and are known as greases or semi-solid lubricants. Now let us discuss the greases in detail. Greases are the products composed of a dispersion medium, which is a liquid, which is retained in the cells of a structural frame formed by solid particles of a dispersed phase, also known as thickening, with particles of colloidal size. Greases behave like solids at low loads. They undergo deforming plastically and become fluid like liquids at a critical load and regain the properties of solid as the load is removed. This ensures proper lubrication of engines and mechanisms when ordinary lubricating oils are ineffective. So in this way, greases have an advantage over the lubricating oils. The best greases retain their properties in friction pairs at temperature from minus 100 degrees centigrade to plus 300 degrees centigrade, rotation speed up to 100,000 RMP, contact stresses about 5,000 MPa in high vacuum, in outer space, underwater, etc. Mineral and synthetic oils are used as the liquid base in the manufacture of greases. Greases are generally prepared by saponification of fat such as tallow or fatty acid with alkali such as lime, caustic soda, etc., followed by adding hot lubricating oil with constant agitation. Soaps which are added as gelling agent give an interconnected structure. At high temperature, the interconnected structure, which is held by intermolecular forces, ceases to exist because soap, which is the gelling agent, dissolves in the oil and hence grease undergoes liquefaction. According to the type of thickener, greases can be classified in many ways. Number one are the soap greases, which are thickened by soaps such as organic salts of sodium, calcium, barium, lithium and lead. Hydrocarbon greases are those which are thickened by paraffins, petroleum and serousins. We have inorganic greases which are thickened by bentonite clays, graphite, molybdenum disulfide. Polymeric greases which are thickened by high molecular weight compounds. The principal operation characteristics of a grease are determined mainly by the thickener. For example, a grease thickened by ceracin, whose melting point is 75 degrees centigrade, can operate at temperatures up to 60 to 65 degrees centigrade irrespective of the type of oil used in it, whether it is the petroleum oil or the synthetic oil. Some grades of greases possess unique properties. For example, greases thickened by perfluorinated alkyl polyesters or polytetrafluoroethylene, that is Teflon, do not react with hydrocarbon jet fuels, hydrazine, hydrogen peroxide, fuming nitric acid, and liquid oxygen. On the basis of applications, greases are classified as anti-friction greases. These decrease friction and wear in friction pairs. Friction greases which increase friction and prevent slippage. Protective greases which prevent corrosion. Dispersing greases which improve the alignment of mating parts. The major portion of greases relates to the anti-friction class. Many of them also possess high protective properties and are called all-purpose greases. Cup greases or calcium-based greases are the emulsions of petroleum oils with calcium soap and can be prepared by adding calculated amount of calcium hydroxide to a hot petroleum oil such as tallow with constant agitation. These greases are water resistant because they are insoluble in water. They are cheap and have widely been used at low temperatures up to 60 to 65 degrees centigrade, but above 80 degrees centigrade, soap begins to separate from these greases. Soda-based greases are petroleum oils thickened by mixing sodium soap. They are soluble in water and so they are not water resistant. They can be used up to 175 degree Fahrenheit in ball bearings, where the lubricant gets heated as a result of friction. Lithium based greases are petroleum oils thickened by adding lithium soaps. They are resistant to water and used at low temperatures only. Excel greases are cheap resin greases which are prepared by adding lime or heavy metal hydroxide to resin and then allowed to stand, as a result of which grease floats on the surface as a stiff mass. It is separated and mixed with filters such as talc and mica. These greases are insoluble in water and so they are also water resistant and can be suitably used for delicate equipments working under low speeds but high loads. Moving on to solid lubricants, the most important solid lubricants that have been widely used are graphite and molybdenum disulfide. Graphite consists of multitude of flat plates, 1 atom thick, and these plates are held by weak bonds so that the force required to shear the crystals in a direction parallel to the layer is small. This causes the parallel layers to slide over one another. Solid lubricants are sometimes mixed with some organic compounds so that they can stick firmly to the metal surfaces. Graphite is the most widely used of all solid lubricants. It is very soapy to touch, non-inflammable, resistant to oxidation by air below 375 degrees centigrade and can be used up to very high temperatures in the absence of air. Suspension of graphite in oil or water is prepared in presence of tannin, which acts as an emulsifying agent. Graphite dispersed in oil is called oil dag, and graphite dispersed in water is called aqua dag. Oil dag is generally used in internal combustion engines because it provides a tight fit contact by forming a film between the piston and rings and hence increases the compression. Aqua dag is used where a lubricant free from oil is needed, for example in foodstuff industry. Graphite greases, that means the graphite mixed with greases, are used at very high temperatures. Molybdenum disulfide has a sandwich-like structure in which a layer of molybdenum atom lies between two layers of sulfur atom. It provides low shear strength in a direction parallel to the layers because of poor interlaminar attraction. Molybdenum disulfide has very low coefficient of friction and is thermally stable in air up to 400 degrees centigrade. Its fine powder may be sprinkled on surfaces sliding at high velocities. As a result, it fills low spots in metal surfaces, forming the film. It has also been used mixed with solvent and greases. Solid lubricants are generally used either in the form of dry powder or mixed with water or oil. The coefficient of friction of solid lubricant lies between 0.005 and 0.01. Soapstone, talc, mica, etc. have also been used as solid lubricants in addition to graphite and molybdenum disulfide. Solid lubricants are used where operating conditions are such that a lubricating film is difficult to be secured by use of lubricating oils or greases. It is used where contamination of lubricating oil or greases by dust or grit particle is not acceptable. For example, in the commutator brushes of electric generators and motors. Solid lubricants are used where the operating temperature or load is extremely high even for a semi-solid lubricant like grease to stick in position. It is also used where combustible lubricants have to be avoided. Moving on, let us discuss the properties of lubricants like viscosity and viscosity index, cloud points, pore points, flash point, and oiliness. Viscosity is defined as the force in dynes necessary for the movement of 1 square centimeter layer of a fluid with a velocity of 1 centimeter per second past another parallel layer 1 centimeter away. The measurement of viscosity is usually done in CGS units and the unit used is Stoke or centipoise. In case of thin oils which have very low viscosity, it is measured in centistokes. The viscosity measured by this method is called kinematic viscosity. In United States, another unit of viscosity known as Sebold universal viscosity is frequently employed in the petroleum industry. It is expressed as the number of seconds required for 60 cc of the oil to run through a standard orifice from a cylinder filled with a definite volume at a standard temperature. In case of lubricants, viscosity depends upon the temperature. It tends to decrease with increase in temperature. Viscosity index may be regarded as the average decrease in viscosity per degree rise of the temperature between 100 degree Fahrenheit and 210 degree Fahrenheit. The variation of viscosity of an oil with temperature is given by viscosity index. So, viscosity index is a unitless measure of a fluid's change in viscosity relative to a temperature change, and it is given by the formula VL minus Vx upon VL minus Vh into 100, where VL and Vh are the Seibold University viscosity of standard low viscosity oil and standard high viscosity oil at 100 degree Fahrenheit. In the case of most lubricants, the viscosity index ranges from minus 50 to plus 110. Solvent refining usually improves viscosity index of oils. Lubricants having lowest possible viscosity index are in great demand for aircrafts, where the bearings are exposed to temperature between minus 80 degrees centigrade and plus 200 degree centigrades. So, the liquids which have low viscosity and low viscosity temperature coefficient are composed of easily movable or flexible molecules, while those having high viscosity and high viscosity temperature coefficient are composed of rigid molecules. This is due to the fact that decrease in viscosity with increase in temperature is due to the increase in the free volume that is available for the molecules to move in. In the case of lubricants having larger molecules, heat also provides energy required to deform the large molecules to make them able to slip past each other and thus decreasing the viscosity. So, viscosity of a lubricating oil also increases by mixing polymers with the lubricants. In practical work, viscosity is measured as SUV as in USA by Seibold viscometer. It is not measured there in centi-Stokes or Poises, where a lubricant is used in the form of very thin film as in rolling contact bearings or in Jenner boundary lubrication. The volatility of the lubricant is necessary to be taken into consideration. When lubricants containing volatile impurities are used, these volatile impurities may escape during the function of the machinery. As a result, the pure lubricant, that means without volatile impurities, may reduce in quality and may cause lubricant starvation. If we use a multi-component lubricant and one or more of the component undergoes volatilization, then the residue may change very undesirably with respect to its property of viscosity, which may increase to a considerable extent. The next property is pour point. It is defined as the temperature at which the oil ceases to flow when cooled under standard condition. This property indicates the dissolved wax concentration in a given sample of lubricating oil and also determines the temperature below which oil cannot be used as a lubricant in the engine. So, learners, in this presentation we have discussed the lubrication, its importance, types, viscosity and pour point. Thank you.